طيب بسم الله والحمد لله والصلاة والسلام على رسول الله وعلى آله وصحبه ومن والاه. Any questions يا شباب before we proceed? Any questions before we proceed? طيب. So today what we will do inshallah is we will finish the last portion of section 7.2 which is regarding random variables. So what is a random variable? Well, a random variable is a function from the sample space of an experiment to the set of real numbers. Okay? From the sample space of an experiment to the set of real numbers. That is, a random variable assigns a real number to each possible outcome. So every possible outcome is basically assigned a value. Okay? A value, any value, any real number value, not necessarily between 0 and 1. We will see now in the examples. Okay? Right. So that's the definition of a random variable. But what about the distribution of a random variable? Well, the distribution of a random variable x on sample space S is the set of pairs R, probability of x equal R, for all R in XS, where probability of x equal R is the probability that x takes the value R, is the probability that x takes the value R. So what does that mean? Well, so the question is, how do I compute probability of x equal R? Well, I can compute the probability of x equal R by, first of all, looking at how many outcomes in my sample space have been assigned R, صح? And then divide by the size of the sample space. And then divide by the size of the sample space. So this is basically what we refer to as the probability of x equal R. Now, a distribution is usually described by specifying probability of x equal R for each R in XS. Okay, a distribution is usually described by specifying the probability of x equal R for each R in XS. You can also, by the way, draw it graphically. Okay, if you would like, you can also draw it graphically. So let's take two examples in this case. Let's start with the first example. Now, in the first example, suppose that a coin is flipped 3 times. Let x of t be the random variable that equals the number of heads that appear when t is the outcome. So if t is the outcome, x of t is the number of heads. Okay? X of t is the number of heads. Who can tell me what are the possible values of x of t? Yes. 0 to 3, صح? So in this case, the possible values of x of t will be basically 0, 1, 2, 3, because in 3 flips, when you flip the coin 3 times, you can either have 0 heads, 1 head, 2 heads, 3 heads, right? Right. So now we would like to see, well, what is the distribution of x of t? Okay, right. So how many of those 3 flips, how many of them will have 0 heads? 1, صح? اللي هو TTT, right? In fact, let's put the sample space, okay? Let's put the sample space. So basically we have TTT, TT head, T head, T head, head, TT, head, T head, T, and finally head. Okay, so how many have 0 heads? Only 1, اللي هي TTT, صح? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 1 So therefore, probability of x of t equals 0 is equal to what? 1 over 8, صح? Because the size of my sample space is 8. The size of my sample space is 8. طيب. Now, we would like to find what is the probability of x of t equal 1, x of t equal 2, x of t equal 3. Now, how many of these equal 1, meaning having one head? We have one here, we have one here, and we have one here, صح? Anything else? No, right? So basically it is 3 over 8. What's the probability of x of t equal to? Well, 1, 2, 3, right? So basically again, 3 over 8. Finally, what's the probability of x of t equal 3? Well, we only have one such outcome, اللي هو h. So it is 1 over 8. So now, this random does this consider to be a probability distribution? What is the sum of all these probabilities for this random variable? 1. Huh? The sum is basically equal to 1. Okay, so this is our first example for using a random variable. We basically look at the outcomes of my experiment, and I assign a value to each outcome. Right. Let's look at another one, which is basically throwing a pair of die. Okay, a pair of dice, right? Throwing a pair of dice. So let x be the sum of the numbers that appear when a pair of dice is rolled. When a pair of dice is rolled. What are the values of this random variable for the 36 possible outcomes? ij, where I and j are the numbers that appear on the first die and the second die, respectively, when these two dice are rolled. So what is my range of this function? What is the range of this function? It's from 2 to 12, huh? Basically, the least value is for 1, 1, which is equal to 2, and the largest value is for 6, 6, when it is equal to 12. So basically, x belongs to 2, 3, 4, all the way to 12. Okay, all the way to 12. واضح يا شباب? So we answered the first question. Now we would like to answer the second question. What is the distribution of x, right? Or x of t. Well, let's say here x of t. Okay. Shall we say x of t ولا t belongs to 2, 3, 4? شو رايكم؟ t is the pair. Yeah. Let's keep it that way. X of t. طيب. يلا يا شباب. So what is the probability of x of t equal to x of t equal 3, x of t equal 4, x of t equal 5, 6, 7, 8. طيب, we need 4 more, so I think we can put them here. Probability of x of t equal 9, probability of x of t equal 10, x of t equal 11, and finally x of t equal 12. Okay? Right. So how many outcomes add up to 2? 1, اللي هي ال 1 1, صح? So what's the probability of x of t equal to 1 over 36? طيب, what about if x of t equal 3? The sum is equal to 3. 1 2 and 2 1, صح? So this is 2 over 36. طيب, what about when the sum is equal to 4? Well, we have 1 3, we have 2 2, and we have 3 1, صح? Do you notice one thing regarding the diagonal, صح? So in fact, let's do this. Let's choose. So basically, this will determine the first one. This will determine the second one. This is probability x of t equal 4. These are all the outcomes with, x of t equal 5. These are all the outcomes with x of t equal 6. These are all the outcomes with x of t equals 7, x of t equals 8, x of t equals 9, x of t equals 10, 11, and 12. Huh? 11 and 12. So now, all what I need to do is, what do you think? x of t equal 5, ايش راح يكون? With 6, 7, 8. صح? Probability of x of t equals 8 is 5. So now we go backwards. So this is 4, 3 over 36, 2 over 36, and finally 1 over 36. And if you sum these probabilities, their sum should be equal to, okay, their sum should be equal to 1. Any question, يا شباب? Any question? Yes. A linear combination? Why do you want them a linear? Here it is I plus j, but linear combination, whenever you say linear combination, whenever you say linear combination, what comes to my mind is alpha I plus beta j. Where alpha, yeah, it's basically I plus j, okay? It's I plus j. طيب. Yes. Can we write what?
Probability of x given any value, like a function, like a regular function, like x squared or something like this, like x minus 1 over 36.
Well, I don't get your question.
Instead of counting each time for any value, we come up with a formula that works for any value.
It's up to you, but if I want to find based according to the definition, you basically count how many outcomes satisfy this and divide. Now later on, after you get that, if you try to find a formula, that's something different.
But when we say the distribution of x, we're basically listing out.
Exactly. Right. So let's now come to this very interesting problem. What is the minimum number of people who need to be present in a room so that the probability that at least two of them have the same birthday is greater than one half. Now, first of all, let me ask another question. What is the minimum number of people who need to be present in a room so that we are sure that two people have exactly the same birthday, day and month? 367, صح? Because we have 366 different days in a year. So using the pigeonhole principle, we need 367. Right. How is this question different from the question on the board or in the slide? Well, the question in the slide says what? Says, how many people do I need in a room so that there is a 50% or more chance, of having two people with the same birthday. So there is no guarantee, صح? But we would like it to be 50% or more. Yes. 366 plus the half. ترى احنا ال 366 plus 1 we are sure انه في اثنين.
Plus half of the 36. 366 plus half 366.
To do what? لحظة شوي. أنا مش فاهم. لا دقيقة شوي شباب، دقيقة شوي. هلا احنا ايش قلنا قبل شوي السؤال؟ We are sure انه في two with the same birthday if we have only 367 اللي هو 366 plus 1. So you would think to have 50% or more chance to have two with the same birthday, at least two with the same birthday, is like 180 something, huh?
It will be less.
Less than 180? How many?
Can you repeat what you said?
Can I repeat what I said? طيب, first of all, I want to see why did they say 366 plus half 366?
This is 550%.
To do what?
To make sure, to guarantee that at least two persons have the same birthday. The probability is more than one half.
أنا لهلا ماني فاهم أنتوا كيف عم بتفكروا. احنا we said there is a 100% probability to having the same birthday if I have 367. أنا إذا كان عندي استخدام pigeonhole, if I have 367 in one room, definitely there will be two with the same birthday, صح ولا لا؟ additional probability 100%. فأنت جمعت نص على 300، ما بتحتاج النص، بتحتاج واحد بس. 1 زائد 366 you have 100% probability that two have the same birthday. So now let me ask you, in your opinion, what does your instinct tell you? How many do I need in a room to have two having the same birthday? At least two, 183. So you took half 365. طيب انت you said much less.
No, I said having the
66
367.
أو 367.
Yeah, we'll give you the.
Will give me. طيب, any other numbers? Yes.
Just a question. I thought the number of years, the number of days in a year is 365.
اللي انولدوا في 29/2 ما بدك اياهم يعني. نزتهم نرميهم برا البحر. Okay. So we have to have the 29th of February. طيب. Okay. So in order to solve this problem, we are going to make some simplifying assumptions. To make our life easier when we try to solve it. Okay? And then you will be surprised at the number. We are going to assume that the birthdays of people in the room are independent. Now, this assumption might not always be true, especially, if you have like two brothers or يعني twins أو حتى without twins يعني once you have two brothers it's not independent, right? Yeah, it's not independent, right? It is not independent. Twins, maybe also it is not independent, right? So this is kind of a simplifying assumption. Another assumption is that we are going to assume that each birthday is equally likely and that there are 366 days in the year. And again, يعني this assumption might not be that realistic, صح? Usually, for example, the wedding parties, usually they take care of when ترى ترى مش in the summer vacation you will have more wedding parties than because you might want your family members from all over the place maybe to come by or for example يعني wedding parties during the weekdays is kind of especially يعني in the rest of the year it's usually on Thursday صح Thursday or Friday right ف يعني these simplifying assumptions are really simplifying assumptions we cannot say that they are absolutely correct but let's make them in order to make our life easier when we solve it. طيب. So now, how are we going to find the probability of having at least two with the same birthday to be greater than or equal to half? We are going to do it using the complement. Okay, using the complement. And at least two, it means 2 or 3 or 4 or 5, صح? فإيش الcomplement? Well, we are going to find what is the probability that n people in the room have different birthdays. Isn't this the complement of having at least 2 or more having the same birthday? شو رأيكم? What is the complement of the event having 2 or more with the same birthday? Isn't it having n people in a room with different birthdays? Yeah, right. And in order to simplify computing it, let's assume that we enter them one at a time. احنا what did we say? We said the birthdays are independent, صح? So probability of when you have n enter, it will be what? Because they are independent, it will be the product of the probabilities that they are different, صح? طيب, what's the probability when the first one enters the room to have n different people with n different birthdays? 100%, صح؟ ما في واحد ما في اثنين, right? طيب, when I enter the second one, فكر شوي. 365 divided by 366, صح؟ لأنه when you enter the first one of the birthdays has been reserved, صح? Now, in order for the second one to be different, what is the probability? 365 divided by 365. What about the third one? What about the third one when the third one enters? 364, صح? So, when n is equal to 1, Pn is equal to 1. When n is equal to 2, Pn is equal to 365 divided by 366. When n is equal to 3, Pn is equal to 365 divided by 366 multiplied by ما تنسى we are multiplying, صح? What are we finding? We are finding the probability that the three have different. For the first one, it will be 1 multiplied. The second one, 365 divided by 366. The third one, 364 divided by 366 until we reach n. طيب. Do you agree with me that in this case, I can write Pn as the product from I equal 1 to n of n minus مش n 367 minus I over 366. ايش رايكم؟ So if you plug in n equal to 3, this will be what? Product 367 minus 1, 366 over 366 is how much? 1 multiplied by when I is equal to 2, 365 divided by 366. When I is equal to 3, 364 divided by 366, right? So this is Pn. This is Pn. So now, what is the probability that at least 2 have the same birthday? It's basically 1 minus Pn, right? It's basically 1 minus Pn. طيب, what do I want? We want 1 minus Pn to be what? We want 1 minus Pn to be greater than or equal to half. Now, how can we find such n? Well, since this is n, the range of n is what? From 2 to 366, huh? We can do it by, there is no need to try to solve it analytically. Just get the values for certain n's, and you will find the result. So basically, if you can find the values of Pn for some values, then you look at 1 minus Pn and see, is it greater than or equal to 0.5 or not? Right. You love using calculators, huh? Of course, you don't have that luxury in the exams, but since you love using calculators, may I ask you to find what is the value of P22 and P23? Yalla, I need the first one to give me these values. طبعا, what does P22 mean? It means I have 22 people in the room, صح? P23, I have P23 in the room. So what is P22 and what is P22 كم؟ 0.94. لا مستحيل. P22 ترى لازم ال P22 عبارة عن ايش؟ 365 divided by 366 multiplied by 364 هيك لحد ما توصل 367 minus 22 اللي هي ايش؟ اللي هي 345 صح؟ multiplied by 345 divided by 366. شوفوا لي قديش بتساوي. ترى once you find P22, if you save it, to find P23, what do you need to do? Just multiply by the next, 344 divided by 366 to get the P23. You don't have to do it all the way يعني again. Anybody got P22 first and then P23? على طول, if anybody finds one of them, just raise your voice. Yes, go ahead. 0.525. طيب, well, P23 is approximately 0.494. شو رأيكم يا شباب? So therefore, what is 1 minus P22? is approximately how much? Is approximately 0.49 something, صح? Will 1 minus P23 is approximately how much? 0.50 something, ولا لا? Right? So how many do we need to have a 50% or more chance of having two with the same birthday? 23. ليش 22? 22.49.
بس في 0.002
لا. 1 minus P22 does not reach 0.5. Right? 1 minus P23 reaches 0.5. Okay? Shall we do that here? Let's see how many people do we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we are on the borderline. In the other section, we had 34. We were counting until we reached maybe the 17th student. Another student, he raised his hand. He said, I have the same birthday. Let's do it. We will do it column by column. If any one of you hears his birthday, not say, يعني, please raise your hand or raise your voice or just do something. طبعا we're going to say day month. Okay? 1/10 4/9 9/7 25/6 30/3 17/6 اوف ايش 17/6. Okay, so now in 2 sections it worked, although we have one more 24, but it worked. Okay, any questions يا شباب? Any questions? Okay, طيب, so let's let's move on and let us go to chapter 8, the last thing that inshallah we will be doing this semester. Okay. Okay. So basically, by the way, we are going to cover section 8.1 and section 8.2 up to and including theorem 2. The rest of the theorems that have generalizations, we will not worry about them. It's enough for us, until theorem 2. So what are we going to do in this chapter? Well, many counting problems cannot be solved easily using the methods discussed in chapter 6. In fact, we will notice that some problems will be much easier to solve recursively. Okay? So let us, look at the first example. We will just take 2 examples today. Inshallah, more examples we will be taking in Thursday. So a pair of rabbits does not breed until they are 2 months old. After they are 2 months old, each pair of rabbits produces another pair each month. Each pair of rabbits produces another pair each month. Find the recurrence relation for the number of pairs of rabbits on the island after n months, assuming that no rabbits ever dies. Okay, assuming that no rabbit ever dies. So basically, this is the figure. So as you can see, in the first 2 months, I have 2 young pair of rabbits that basically, since they are not old enough, they do not breed. So basically, the total number of pairs is 1. Right. On the 3rd month, they will produce 1 young rabbit. Huh? So on the 3rd month, how many pairs do I have? I have 2, right? Right. On the 4th month, the same pair will give birth to a pair, but this original pair will be how old? How old this pair is going to be? It will be 1 month, صح? Here it will be 1 month, so it will not breed, right? So here we're going to have a total of 3. But when we go from the month 4 to month 5, the number of breeding rabbits will increase, صح? Because this pair now is 2 months old, so it will come here. And now each one of those will have 1 pair. And of course, we have the one that is 1 month, that is 1 month old. So how many do we have? In this case, we have 5, right? And then you continue. Now, look at the total number of pairs and tell me, is there a recurrence relation that you can...
Let's add 0 to the total, then add 2, then add 3. It's increasing.
It's Fibonacci. So basically, Fn is equal to what? Fn is nothing but... Oops. Fn is nothing but Fn minus 1 plus Fn minus 2. صح? Fn minus 1 plus Fn minus 2. So for example, here, F6 is F5 plus F4, right? Right. Since I have the recurrence based on the history of 2 values, how many initial conditions do I have to have? I have to have 2, صح? I have to have 2. So therefore, what are my initial conditions? ليش 0? F1 equal 1 و F2 equal 1, صح? F1 equal 1 و F2 equal 1. F1 equals 1 and F2 is equal to 1. But let's now take another example of using recurrences in order to count certain things. So this is basically the towers of Hanoi. I have n discs of different sizes, and I want to move them from one peg, one pole to another one. Okay, but I have one restriction. I cannot put a bigger size disk on a smaller size disk. Okay. Now, what is the idea of? So basically, if I have n pegs, if I have n disks, I would like to find how many moves do I need to do in order to move the n disks from one peg to another. Now, what we can do is we can represent the n, this number. We can represent this number of moves as recursively, just like what we did in chapter 5 when we looked at induction and the well-ordering property. Okay, so we're going to assume, let's assume that to move n disks from one peg to another, I need hn moves, right? So let hn be the number of moves to move n disks from peg 1 to peg 2. Of course, we are using the temporary peg or peg 3 in order to take care of the restriction that we cannot have a larger size disk over a smaller size disk. Right. What is the idea of the solution? Well, the idea of the solution is that in order to move the n from peg 1 to peg 2, first move n minus 1 the top n minus 1 from peg 1 to peg 3. Okay, so you move the top n minus 1 from peg 1 to peg 3. And then what do? Move the last one, the bigger one, the biggest one, from peg 1 to peg 2. And then move the n minus 1 back, but instead of to peg 1, now we need to move them to peg 2. So in this case, what is the value of Hn? How can I represent the value of Hn? Hn will be equal to what in this case? 2 times Hn minus 1 plus 1. Basically, Hn minus 1, to move the n minus 1 from this peg to this, right? We need Hn minus 1, to move the top n minus 1 pegs from here to here. And then we need 1 here, and then we need Hn minus 1 to move from this peg to this peg. So basically, we need 2 Hn minus 1 plus 1. طيب, how many initial conditions do I need? 1. So H what? H1 is equal to what? 1. If you have only one disk, you just need one move to move it from one peg to another. Okay? طيب. Now, if I give you this, how can I solve it? I can solve it using iterative expansion, صح? I can solve it using iterative expansion. So let's use iterative expansion. And so basically, Hn is equal to twice Hn minus 1 plus 1, صح? Now, if I put here Hn minus 1, ايش راح تساوي؟ 2 Hn minus 2 plus 1. ترى if you do this, inshallah, you will never make a mistake. Okay? So this is equal to what? This is equal to 2 square Hn minus 2 plus 2 plus 1. ترى until now, the pattern is not that clear. Let's do the expansion one more time. Okay? So this is equal to 2 square Hn minus 2 plus 2 plus 1. Also, don't add them up. Keep it like this. Okay? Don't add them up. Keep it like this. طيب. So if we put here Hn minus 2, if we put here Hn minus 2, no, here, Hn minus 2, it will be 2 Hn minus 3 plus 1. 2 Hn minus 3 plus 1. What is this equal to? 2 cube, صح? Hn minus 3 plus 2 square, ما تخليها 4, 2 square plus 2 plus 1. Do you see the pattern now? Now the pattern is very clear, صح? Who can tell me what is this equal to? In general, if I continue like until k, 2 to the power k, Hn minus k plus k minus 1, صح? Plus 2 to the power k minus 2, all the way 2 to the power 0. Okay? 2 to the power 0. طيب. Now, we are going to continue the expansion until what? Until n minus k equal 1, صح? We will keep reducing until n minus k is equal to 1. So, we will keep expansion or expanding until n minus k equal 1, which means k is equal to what? K is equal to n minus 1. So now, if k is equal to n minus 1, what will be my formula here? It will be 2 to the n minus 1, 2 to the n minus 1, h1, we made it, صح? We made it so that we will have h1, plus أيوة 2 to the n minus 2 plus 2 to the n minus 3 plus 2 to the 0. طيب remind me, h1 is equal to what? h1 is equal to 1, صح? So this is what? This is 2 to the n minus 1 plus 2 to the n minus 2 plus 2 to the n minus 3. So how can I write this? This is summation. Chapter 2 معانا ولا مش معانا? Okay. Summation. أيوة. From I equals 0 up to n minus 1 of 2 to the power I. Sigma 2 to the power I from I equals 0 to n minus 1. Now, do you remember the formula? I remember the formula. It's basically 2 to the n minus 1 plus 1 minus 1 divided by 2 minus 1. What is this equal to? 2 to the n minus 1. Okay, Shabab? So, in this way, we basically found the number of times, the number of moves that we need in order to move the n disks from one peg to another. So let's stop here. I'll take the attendance, and then inshallah we will look at more interesting problems بإذن الله on Thursday. Okay.